There, let's try that again. Hey, welcome everybody to WAVY Science Lab. I'm meteorologist Jeremy Wheeler, and we're going to be talking about something that is topical, tides, and those tides are affecting our area. Well, we just had one affect us just recently, but the tides have really affected the area because we've had all those homes fall into the oceans over the southern Outer Banks, and that's tidal flooding. But tides in general, we're going to talk about how they work and how they form today. So let's get into it and let's take a look at what we've got. So again, tides, they are affected by the Earth, the moon, the sun, all of those working together. Tides are caused by gravity. And so we have to kind of back up a little bit. Gravity, not just a John Mayer song. Nope, it's a technical aspect, force of attraction between two objects that have mass. So something has matter and it has mass, then, there's a different density. Some objects have more mass than others. Some are larger, of course. That's kind of the main way we measure. But, if the object's more dense, then that could have more mass. Could be misleading a little bit. But, yeah, so these objects have mass and they have some attraction in there. Now, the more mass equals stronger attraction. It decreases with distance. It decreases big time with distance. And so that's why the sun and the moon, we're going to talk about that, how, that one's so much larger, of course, than the other, but they're also much farther apart. All right. Now, these bodies that are in space, the moon is the main driver of the tides. It attracts the water in the earth. Even though the sun is much larger, the moon is much, much closer. And so the moon revolves around the earth and the water is pulled around the earth. And, it's daily, right? It's happened throughout the day, and we get the high tide twice a day. So the sun also pulls on the water, but it's a little bit different. So the sun, of course, is in the center of the solar system. The Earth goes around that, and then the moon revolves around the Earth. And so, pull out a very large Earth here. Let's take the whole camera. So we've got the Earth. And the moon is going around it, right? And so it's pulling that water in that direction as it revolves around the Earth. And then the Earth is rotating on the axis. And so that's why there's the difference in the sun. So sometimes they meet up, right? The moon can be a new moon. And let's use the graphic for that. Let's go back to that. And so if you have a new moon, then you have the moon lined up with the sun at certain times of the day. And so there's that extra pull because the sun and the moon are both pulling on it in the same direction. When you have a full moon, well, I mean, it's still pulling on it. And then the earth is exactly, the sun is exactly opposite. So it's pulling in that direction. And then you call that spring tide. You think, well, in the spring, the season of the spring, why do you call it that? Think about it, a spring, this kind. Yeah, it's from Old English, springing, I think. And so there's that effect. And then if it's out of phase a little bit, you got the moon pulling, but the sun is, off in the other direction, then you get the neap tide. So hopefully that makes sense. I kind of wish some folks were in this room so I could explain a little bit better, but hopefully the graphic here explains it. You've got that attraction between the moon and the sun and the earth. And so they work together. And so at different times, you can get different phases of those tides and you get the different moon phases, right? And so there they are. All right. So this happens throughout the day, goes around the planet. And the sun is 100 times wider than Earth. So, of course, it has a lot more mass to it, 10 times wider than Jupiter. And I use this when I have my sun podcast. The diameter looks at 865,000 miles. That's a big enchilada. Because gravity holds the solar system together, basically. So the thing is the distance. So the moon is a lot closer than the sun, and I don't even think these are to scale, I don't believe, but it just gives you an idea. So, the moon diameter, 2,159 miles, the sun diameter, 865,000 miles there. So I think we just kind of talked about that. But it's 400 times farther away. So that makes a big difference, in that gravity. If it was closer, maybe it would be the main driver because it's so much more massive. But the distance makes a big difference. And so that's why the moon is the main driver, but the sun is also a player in the game. So if Earth was a perfect sphere of water, then water would flow perfectly around it. It would just, there wouldn't be a delay, but there is, right? You have these land masses that get in the way. And so the timing of the tides isn't, well, I mean, it's set. I mean, you can actually look at tide charts, far out in time, but, it creates that difference, big difference in height among the tides. It collects. So the way we measure it are these old, this is an old tide station. We do it with tide stations, but this is an old one, and this is compliments of NOAA, and you can see the link there. And so it used to be more analog. It used to be that you have a gauge in there and probably a wheel and probably maybe a marker or a pen or something. And so it would mark, and you'd get a graph with that tide height. And, that's the old station. You get the water level, and then it raises the float. And then there's the wire, and that goes with the gauge. That's an old tide station. But now everything's automated and electronic, and so this is a new tide station, and you can see even acoustic sensor. Whoa, we're getting real fancy there. You got the well, and then you've got the antenna because it's a data logger now, electronic data logger, and so that sends it probably to the main hub for NOAA, and then they get that data real time, and so we do too, and that's really cool stuff. You got a backup data collector, and so that water level, you got a pressure sensor as well, and just really neat to see how that works. Now, we get tidal flooding around here. Water gets up into the Chesapeake Bay. That swells and pushes it back up into the river systems, and so this is a common example. This is tidal flooding at Air Power Park, a photo that we had in our system, and so there's a good example. There's some tidal flooding at a marsh. I don't know if that was local. I think it is local. I do believe that was also in our system. And then this is in Hampton. You had some tidal flooding. And this tidal flooding can get pretty bad. We had one just recently. It was pretty bad. And up the peninsula, middle peninsula, south side, it swells up that Chesapeake Bay. We had a system come in and push the water levels up. And so it can, flood out homes. It can get up into the homes and cause damage, water damage. And that's really tough because then you get mold. And you have to strip out the whole bottom when that happens. A lot of homes are raised, but some are not. And so, that looks like that one might be raised a little bit with maybe a concrete bed. Hard to say. But, and then here's another one. This is in Norfolk, so some more tidal flooding. All right, we're going to have more information on this coming back in just a little bit. So stay with us, and we'll talk more about the tide. All right, welcome back, and we're talking about tides today. We just had some graphics about tidal flooding and talked about some examples around here. So now we're going to move on and talk a little more about the highest tides on Earth. We have some pretty bad tides here sometimes, but boy, it's nothing compared to some other parts of the Earth. And we talked about, those land masses cause that collection, kind of the water to collect and get a little higher in some spots than others. So in the world, the Bay of Fundy is the highest one. Nova Scotia, Canada, about 53 feet. Whoa, that is that's pretty impressive, if I do say so myself. Think about that, 53 feet on a daily basis. Well, that might be the record, I believe, but on a daily basis, about 40 feet ish. And so let's take a look at that. The Bay of Fundy is amazing. I'd love to check that. Well, we'll show you the photos in a little bit. But in the U.S., Cook Inlet in Alaska, the average is 30 feet. So that's taller than some two-story homes, and that's just amazing. So here, about 1 to 2 feet. Ooh, that's really something. So these tides. So here's the Bay of Fundy, and this is probably around low tide, maybe not the lowest tide, because I think I've seen it to where it goes out a ways. But it's definitely going into low tide or coming out of low tide. And look how much ground is exposed there. So then it starts changing, and this is probably about halfway through. I think you call that slack tide, where it's about halfway between the high tide and low tide. And so folks go out, as long as there's no big waves, it's okay probably to get out there and see that. We have tides here in Hampton Roads, the ocean, and we can still swim in it. So it's probably safe. But if it was really wavy or really stormy, then I wouldn't touch that with a 10-foot pole. But speaking of 10-foot poles, take a look. So now the water comes in, and you can even see that's not even the top of the water line or the bottom of the water line. But it can get even higher than that. So it's just amazing to see the difference between those. Just from, the first one to the last one there. And Again, that's the Bay of Fundy, and a good example in Canada. All right, now we do get some tidal flooding here, some comparisons. This is the tide, but it's also storm surge. So it's the total water rise, but still, we call it the tide comparison. So Isabel, 2003, that's our biggest one that we've had here on record. That was 7.89 feet. That was pretty bad. It was right before I got here. I got here in 2004. And then the nor'easter 09, I was here for that one. That was about a week. That was about a week of tidal flooding. We had it so bad that a fire truck brought us in. It got stuck because there was a recess and didn't plan for that. So they brought a boat and brought us into the boat. It was me and Stephanie Harrison at the time, and then another Stephanie here. And they brought us in. So amazing. Sandy, 6.81 feet. And then the one we had recently was 6.18 feet. So that was also pretty bad. And then we had the king tide at the same time, so that goes back a little ways. But that king tide is a naturally higher than normal tide, occurs during the new or full moon. But the moon is at perigee, so the moon is closest to the Earth at that time. Because remember, I mean, it does rotate around, but it's not in the exact same spot every time. Sometimes it gets a little closer, sometimes it gets a little farther, and so closer, and so that causes that effect. And so a couple times a year you get the king tide, and we had that during a tide recently, a tidal event. And then so you got mean sea level. I think everybody kind of knows what that is. That's kind of the average between the highest and lowest tide, right? And I mean, that varies for us. There's different land heights and different water heights. So that our mean sea level, that's what that is. It's the average between the peak and the bottom, right in the middle. And then you've got these other ones, mean high, higher tide. So we're talking about the average highest tide, mean higher high water. That's the top. That's the average highest tide that you can get, the peak there. And then the highest observed. And then mean low water, kind of the average low water, but mean lower low water. I know that's kind of confusing, but we use this. I mean, this is what we use in the Weather Center. That mean lower low water, that's what we use for the tide levels. And so that one that I just gave you about the tides, in Hampton Roads, these are mean lower water. All right, that's a lot. But if you don't get it, that's okay. But that's what we have. That's what we do. And so that's the different tide levels. Call them the datums. Tidal datums. So that's what we use. And then this was a recent tidal event that I've talked about that we had. And so we forecast it out. We have models from the National Weather Service. One's called the slosh model. We won't go into what that is, but basically it gives us the forecast. But it's based off of models, and weather models, so it's not always correct. So we try and figure out, and get a best sense of if it's going to be a little higher, a little lower. In this case, at one point, it was supposed to be, or it forecasted 7 something, up on the level of Isabel. And we thought, well, that's not going to happen. The system, and it didn't. It ended up 6.1. It's very difficult to forecast that. So we did have, and I said yesterday on the text here, but that it was from a recent example. And so we had some tidal flooding around Yorktown. We had it on the peninsula, middle peninsula, the south side. And so there it was, and you can see, I mean, that got pretty bad. There was in Norfolk, and it covered over the roads, and that's a problem. It's hard to get around. And, it just causes a lot of problems. This is another one up around Hampton. Alex, it looks like it got up close to the home. And then this is truck, looks like it made it okay, through the water, but, you're not supposed to drive through that. So we had some video as well. And so I want to show that, folks driving through the water. So, they do it. You're not supposed to. I've done it when I could see the road, but the problem is, when you can't see the road, that's when you got to stop, turn around, don't drown. And even if you can see the road, the problem is sometimes you get those recesses. Sometimes there's a hole or something, maybe a pothole. You can't see that, and so it can get flooded out. Now, it's different for us in that we don't have a lot of moving water. When it comes to that tidal flooding, it just comes up. So that does make a little bit of a difference. And we're going to talk about that in the next segment. But still, I mean, you can get some flooding that can get up, in your car, and then you can get mold on the bottom. But also, if it gets in your tailpipe, or in the engine, then you're toast because that water gets in the engine and it'll ruin the engine. And so this is all some footage shot by our photographers around the area. And so again, that water gets up into the Chesapeake Bay, that swells, and it pushes the water up into the rivers. And so our waterway system, it's complicated. It's Hampton Roads, and it just causes a lot of problems when we have these systems that sometimes are even offshore. A lot of these, I think, this one I'm talking about, it was offshore. Some of these don't even come in. We've had a couple of hurricanes way out to sea. Aaron, I think, was an example. We still had tidal flooding here. It still pushed the water our way. So that can happen, and it makes it complicated. But another thing is poor drainage. Sometimes you can get water to have poor drainage. We're going to talk a little bit more about that coming up. Stay with us. We are back, and today we're talking about tides. We've just seen some pretty interesting things, talking about the water levels. Let's go back to that. And so, I talked about tides coming in and causing problems, but also you get poor drainage. That's a new aspect that we kind of have had to talk about the last few years. It's been there for a while, but I think it's more of a factor now. So the thing is, these tides come up, and then the drainage systems they're plugged up. Sometimes they've been in backstoppers, and so they won't drain. So if you get heavy rain, it'll compound the problem. Hurricane Matthew, we had some tidal flooding, but really the tidal flooding itself wasn't that bad. It was pretty bad, but it wasn't that bad. But we had flash flooding, and that created a huge problem. It was 2016, Hurricane Matthew, and so the flooding just from the heavy rain caused a lot of problems because of the poor drainage aspect. So that's really something to think about. All right, so let's move on to explain, some of the storm surge and what it is. So you've got the predicted tide. Maybe it comes up a little bit naturally, like the king tide. You have mean sea level there, and then storm surge. So storm surge comes from these hurricanes or a strong system, and it will literally push the water up. So the hurricane will push water up. There's your normal sea level. You get the storm surge in there. There's the wind coming in, and it pushes that water level up higher. 1 foot, 3 feet, 6 feet. Now we're talking about water getting up close to homes. And then in some of the worst cases, you can get that water level to rise up, 12 feet, 15 feet. Hurricane, pardon me. Brain freeze. Hurricane from 1969, Camille, caused a 20-foot storm surge. And then there's another one, 2000, Katrina. Thank you. I thought of that myself. Hurricane Katrina, 2005. It was about 20 feet or so down across the deep south. So think about that, a 20-foot storm surge. That's terrible. Because not only that, in the storm surge, you also have waves coming in. And so that is over it and over the tide, and that will compound the problem. That happens for us too. So our flooding risk locally, we've got the different levels. Nuisance tidal flooding happens quite a bit. It maybe causes a few issues, especially the folks that live, low-lying areas like The Hague. But minor tidal flooding, now you've got it in the typical flood zones. They're affected a little bit, some street flooding. And a few minor problems, no big problems though. And usually it's not getting up into homes. When you get moderate, you get a lot of street flooding. Now some homes are affected, and some docks can be covered. Bad, pretty much right near the shore. But major, you can get major tidal flooding, and so widespread street flooding, water into homes, and many areas just impassable. So we had that tide example from not too long ago, and so we had some moderate tidal flooding, but there's some levels, and that was Sewell's point. There's some other areas in there that had major, and they had water coming up into the homes, and so that was forecast pretty well, but that happened. What do you do? Well, you bring your valuables up off the floor. In some cases, if it's really bad, folks have to plan on going up maybe in the second floor or elevate themselves in their home. All right, so let's go into the next one. So some flooding safety tips. If you're in a vehicle, never drive through flooded waters. Again, if you can see the road fine, you're kind of familiar with the road, might be okay. But if you can't see, how deep it is, then turn around, find a different way. The water may be deeper. The road could be washed out even. More so if, it's a flowing water, but that could happen. Stay out of the water. A lot of folks get in there and they think, I can play around in here, but it contains debris, pet waste, chemicals. Avoid the ditches. culverts, and be prepared to move. So 6 inches of fast-moving water can knock over an adult and carry them away. 12 inches can move a vehicle, a small vehicle. Now, that's moving water, right? Around here, the tide just comes up and sits. But still, you still have to plan in case this happens. Sometime maybe you live near a river, and then that water's coming up. Or maybe the mouth of Chesapeake Bay. 18 to 24 inches can carry cars, vans, SUVs, and carry them away. And you can see a flooded-out vehicle right there in the distance, and it's toast then, because it gets into the water and you get all that engine damage, and that's not good. That's no bueno. All right, tidal flooding at night. That's another thing. Now look at that road, right? Can you tell how deep it is? Because maybe it drops a little bit more right in the middle there. You can't tell, so that makes a big difference. That's why driving at night is very dangerous. If there's tidal flooding, you just then definitely turn around, don't drown. And let people know where you're going too. Always let people know where you're going if there's something like that. Tidal bore, what's that? Ooh, it's not boring. It's rapid water movement. Water in a shallow estuary moves as one massive wave. And these are pretty rare. I mean, they do happen around the world. There's at least several known ones, I think, common ones, and then there's other smaller ones, but can be up to 20 feet. Now that's very rare. But this is an example from Noah, and that's the wave there in the distance. I mean, that's really something that's coming at you. So these tidal bores happen in these shallow estuaries, and sometimes the water just collects all at the same time and then comes in or goes out. And I've seen them. I've seen video of them. I don't have video, but it's really interesting to see them. I mean, just one long wave, one huge long wave coming in, kind of like a tsunami, but a little bit different. It's on a smaller scale than a tsunami. Estuaries, partially closed area where fresh water and salt water mix. Bay, so we have one here. A sound, we have several of those, and salt marshes, etc. That's an estuary. And so nutrients like oxygen, phosphorus flow in from the rivers and get in there, and then the ocean brings in sediment, creates these mud flats, and they're nutrient rich. And so there's a lot of wildlife that lives along that and requires it. I mean, the crabs, fish, otters, birds provides a habitat for them, these estuaries. And then in the tidal zones, tidal pools too, for crustaceans, things like that. There's a buffer zone. It's a buffer zone for these tides and storms. And then it reduces pollution, captures and stores carbon. So they're very necessary. The Nile, for thousands of years, the Nile caused flooding. And so the farmers used that because it would flood it out and they'd lose some crops possibly, but then the nutrients would be there and then they'd have some great, harvests. So Aswan Dam, built in the 1960s, tamed the river, but it stopped the nutrients from coming in from the ocean and going out to the ocean. And so, not completely, I don't believe, but cut it off quite a bit. All right, so that's it for tidal flooding today. We're going to finish off with the environmental tip of the day. Tip of the day, lad. Recycle old batteries. They're harmful. They're toxic at dumps. Lots of folks don't realize how many batteries they're putting in there, especially the newer ones, the lithium ion. So many businesses take and recycle batteries now. So that's what you want to do. Take them in, find a place. There's e-cycling, things like that. They take batteries. And so it's just a good way to keep the environment clean. All right. Well, hopefully you learned something today. We get tidal flooding here all the time, and now hopefully you'll understand it a little bit better. Everybody have a good day.